momentarily. Thank you. Again, today's call is being recorded. If you have any objections, you may disconnect at this time. Thank you.
I'll wait for you, Cedric, to tell us we're ready to go.
You are live.
Hello, everybody, and welcome to this media telecon about our newest NASA mission, PREFIRE. My name is Karen Fox. I'm with the Office of Communications at NASA here at headquarters in Washington, D.C., and we're going to be talking today about a new mission within the Earth Sciences Division that is called PREFIRE. It is made of 2 CubeSats, which will be studying what's going on at the poles. You'll hear a lot more about that today. The first CubeSat is scheduled to launch on May 22nd via the launch provider of Rocket Lab down in New Zealand. We have 4 speakers who will be introducing, starting off with a few comments, and then we'll take question and answers afterwards. Our speakers today are Karen St. Germain, who is the Director of the Earth Science Division at NASA headquarters. We have Mary White, who is the Project Manager for PREFIRE at NASA's Jet Propulsion Laboratory in Southern California. We have Tristan L'Ecuyer, who is the Principal Investigator for PREFIRE at the University of Wisconsin-Madison. And finally, we have Peter Beck, who is the CEO and founder of Rocket Lab. As I said, afterwards, we will take questions. To get into that queue, you can press *1. And with that, Karen St. Germain, take it away.
All right. Hello, everybody. Thanks so much for joining us this afternoon. I'm going to speak to you just for a few minutes about how PREFIRE fits into the larger Earth science portfolio. So the PREFIRE mission joins more than 24 other NASA Earth science missions that are orbiting the planet right now, measuring attributes, features of our oceans, land, ice, atmosphere, and vegetation. The scientific research and analysis from these missions enables us to better understand how the whole Earth works as a system. And this is something you can only do from that unique vantage point of space. That's the only place from which you can see the whole globe. And that's especially important when we're talking about otherwise inhospitable locations like the polar regions. So even though PREFIRE has fire in the name, it is actually a polar-focused mission. It's looking at the Arctic and the Antarctic, and we're looking for new insights into how Earth's atmosphere and ice influence how much heat the polar regions lose into space. This new information, and we've never had it before, will improve our ability to model what's happening in the poles, what's happening in climate, and ultimately our ability to predict everything from weather to climate. This is important to our strategy of providing Earth science that is actionable and can inform decisions for communities around the world on how to respond and adapt to changing environmental conditions. PREFIRE is also a really great example of how we can target our research efforts, how we can answer targeted research questions with more affordable options. CubeSats like PREFIRE represent the flexibility in our efforts to reach space. It's a much smaller payload with launch services provided by a commercial partner, all at a lower cost. So this can be really key, especially for answering these really targeted questions. NASA needs both our large missions and these smaller missions. You can think of them in some ways as generalists versus specialists to answer that full range of questions we have about understanding the Earth as a system. So with that, I will hand off to Mary White, our project manager, who will tell you a lot more about the mission itself. Mary, over to you.
Hi, I'm Mary White, PREFIRE project manager, and I'm here to talk about the instruments and the CubeSats. We have two identical instruments that will each fly on one of two identical CubeSats. That is one instrument per CubeSat. Note that these CubeSats are about the size of 2 loaves of bread, or perhaps the size of a shoebox for a pair of hiking boots. The instruments at the heart of PREFIRE draws on JPL's proven technology that was re-engineered for use in this CubeSat. The CubeSats will be launched into asynchronous near-polar orbits. The first CubeSat has been integrated to the launch vehicle. It's been encapsulated, and we're now, it is ready, we're waiting for launch. The second CubeSat will be integrated over the next 2 days, and the operations teams at Jet Propulsion Laboratory and Blue Canyon Technologies are ready, and we are very excited to be launching soon.
Thank you so much, Mary. Next up, we have Tristan L'Ecuyer, the principal investigator for PREFIRE.
Yeah, thank you. I'm going to share a little bit more in detail about the science behind our polar radiant energy in the far infrared experiment, or PREFIRE. The first thing you might be wondering is, why are we even interested in studying radiation in the polar regions? So just as a little background, I'm sure you're all aware that the Arctic is warming faster than anywhere else on Earth. And that has huge potential consequences, both for the local population and habitat for the wildlife there, but also globally for things like sea level rise and actually the weather systems around the planet. I should also mention that we are starting to see some alarming changes in Antarctica as well, with warming starting to destabilize the ice sheet down there. And so we also need to understand what's going on at the other pole. So the goal of PREFIRE is to start to monitor the amount of heat that is being radiated to space from the polar regions. This is critical because it actually helps to balance the excess heat that's received in the tropical regions and really regulate the Earth's temperature. And the process of getting the heat from the tropical regions to the polar regions is actually what drives all of our weather around the planet. So the heat loss in the polar regions is critical for everything that we experience in terms of weather around the planet. What PREFIRE will do is measure the spectrum of the emitted heat from both polar regions. And in particular, it's going to measure the far infrared portion of the spectrum, which is the wavelengths longer than 15 microns, that make up about 60% of that total energy that's lost to space in those regions. But we've never measured that before, as Karen pointed out at the beginning. So what that's going to allow us to do is, for the first time, it's going to allow us to understand what the different processes in the polar regions, like clouds, like humidity in the atmosphere, and like the changing surface, going from an ice surface to a liquid surface, does in terms of altering that heat loss to space. Ultimately, that information then is going to be combined with our climate models, and hopefully we'll be able to improve our ability to simulate what sea level rise might look like in the future, and also how the polar climate change is going to affect the weather systems around the planet.
Thank you so much, Tristan. Our fourth and final speaker today is Peter Beck with Rocket Lab.
Yeah, thanks very much. Look, we're tremendously excited, obviously, to launch these two missions. Our role is to ensure that these spacecraft arrive, both of them arrive safely in orbit. The uniqueness about this mission for us is they're two separate launches back-to-back days apart, and it's really only the Electron rocket that enables these kinds of missions with the unique ability to launch to two different places in space in short succession. So the rockets are down at the pad. We're ready to go. We're looking forward to the 22nd of May and counting down to T0.
All right, thank you, everybody. We do have time now for questions. We can go into a little bit of deeper detail on everything that is planned here. Our first question is from Josh Dinner with space.com.
Hi, thanks for doing this. My question is for Mary. Can you talk a little more about the instruments that are going to be on the satellites, if the probes are testing out new detection devices, or are there applications where this technology has been used before? Thanks.
Yeah, so the instruments are thermal infrared spectrometers. These are, the optical system is an Offner-based system, which has been flown on quite a few various missions, both airborne and spaceborne missions for Jet Propulsion Lab. It's probably most similar to the Moon Mineralogy Mapper optical system, but it had to be scaled down by about a factor of 4 in volume. The detectors are thermopile detectors, and they have flown before on 2 spaceborne missions, the Diviner instrument and Mars Climate Sounder mission. And although it's a developing technology, these thermopile detectors, we're flying more pixels on each detector than had been previously flown. We have an array of 8 pixels in the spatial direction by 64 pixels in the spectral direction.
Thank you so much for that answer. Our next question is from TJ Deere with the Canadian Broadcasting Corporation.
Hi, everyone. So like I said, like I heard, my name is TJ. I'm with the CBC. It's actually quite fortuitous that I'm here today because I'm actually calling from the Canadian Arctic. I'm based in Iqaluit in Nunavut right now. So we're obviously seeing the effects of melting ice caps and climate change firsthand. We're seeing it right before our eyes. So, but I'm curious about what will happen to the information you gather from the satellites. Is there a plan to share it with Canadian bodies like the Canadian Space Agency or maybe other Canadian bodies? What's going to happen with the information?
This is Karen St. Germain. I will jump in here, and then I will. I'll say make a few broader comments, and then Tristan, I'll throw it over to you to talk about maybe if there's any broader participation on your science team. So the first, and if you remember only one thing about this question, it should be that all NASA data are open and freely available to all scientists or all people who are interested around the world. That's part of our open science data policy, and that will certainly be true for this mission. Of course, immediately following launch, we will have a period of commissioning and calibration and so forth. But after that, we always make our data freely and openly available. And then, the other thing is one of the major focuses of the Earth Science program in general is to drive our science insights and information out into communities who can make use of them. And we have and are always looking to create new partnerships with folks who are interested in participating with us on that. So that's the broader answer. Tristan, you may have more specifics in the case of PREFIRE.
Yes, thank you very much, Karen. So again, this is Tristan L'Ecuyer, University of Wisconsin. I'll actually start by saying that I was born in Halifax, Nova Scotia, so I'm Canadian myself, and I'm aware and very always interested, let's just say, in kind of working with some of the climate modeling community in Canada. So the short answer to your question is absolutely. We have some connections already with some of the climate modeling groups in Canada, the people that run the CAN-ESM model, so the Canadian climate model. I also have some connections with people at the University of Toronto and at McGill University who are very interested in getting their hands on the data to understand, again, this far infrared portion of the spectrum that we've never been able to measure before, the 60% or so of the energy that's being emitted from the polar regions, which really plays a critical role in how fast the Arctic is warming relative to the rest of the planet, and how quickly glacial ice will melt, raising the sea level, and also how quickly the ice around the archipelago in northern Canada is going to recede, and whether or not that will open up shipping lanes and things like that in the future. So we have some current plans, mostly with academic people in universities. As Karen said, the data will become freely available to everybody who wants to look at it. And I would actually also be very interested in trying to make connections with some of the other agencies in Canada that maybe deal with the commercial sector and the shipping in the Arctic region. So I'm happy to work with anybody who wants to, and I do have some connections already up there. Hopefully that answers your question.
Yeah, that was great. Thanks very much.
And this is Karen. I can jump back in because there's a couple other things I should have probably mentioned. NASA has an ongoing collaboration with the Canadian Space Agency on related work, including our atmosphere observing system, which is a larger set of missions that are in development now. And in particular, the Canadian Space Agency is working on a mission an instrument called PREFIRE, which is thin ice cloud in far infrared emissions. So we have a broader collaboration with our Canadian counterparts that always does involve exchange of data, but also in the future exchange of hardware and collaborating on flight missions as well.
Perfect. Thanks very much.
All right. Next up, we have Jeff Faust with Space News.
Good afternoon. Two questions, if I may. One for Mary and Tristan. What's the benefit of flying 2 CubeSats versus just one beyond simply having the additional data coming in? And then for Peter, I'm assuming you have a lot of excess performance available with Electron since each rocket's only carrying a single 6U CubeSat. Do you have any secondary missions or other tech demos you're going to plan to use Electron with on those launches besides deploying the PREFIRE CubeSats? Thanks.
Okay, this is Tristan. I'll jump in and try to answer the first question because that's a very exciting and unique portion or aspect of the PREFIRE project is the fact that we will be able to use these relatively lower cost platforms to launch 2 different satellites. So with the help of the Electron rocket and Rocket Lab, we will be able to put these 2 satellites into very different orbits, orbits with different crossing times in the equator. And the idea is that then as they go around the Earth, having one CubeSat would be able to sort of map out what the emission looks like in the polar regions, but having a second CubeSat that flies over then about 6 hours later will be able to understand how changes, something like melting of the ice sheet or a cloud forming or an increase in the amount of moisture in the atmosphere, how that affects the emission between the 2 different CubeSats. So we'll be using the 2 CubeSats to make measurements over the course of several hours apart, taking the difference between those measurements and trying to understand how the processes that are occurring in the Arctic are actually affecting the emission from the Arctic.
All right, thank you so much. As a reminder, you can get on the... you want to add something?
No, there was a second
second question for Peter. I forgot.
Yeah, sorry. No worries, yeah. Hey Jeff. You're right. We do have significant excess performance here. But there is no other missions on the vehicle or tech demos. It's absolutely dedicated to this mission's successful. So just these spacecraft on board.
Great, thank you so much. Now I will pass to the next question. A reminder, you can get into the queue by pressing *1. We do have time for a handful of more questions. Our next one up is Emily Speck with Fox Weather.
Hi, thanks for taking my question. I think this would be for Mary or Tristan. How soon do you expect to begin operating in orbit and seeing data from the poles? Do you need both spacecraft to be in orbit before this happens?
Why don't I start on answering this? We expect to, the CubeSats will actually open themselves up and be operating in about an hour and a half after launch. Our first opportunity for a ground station contact will probably be about 5 hours after launch, and that applies to the first launch. For the second launch, we haven't yet calculated, but it's probably something similar. The CubeSat itself, its subsystems, the bus needs about 5 days for checkout, and then they will turn on the instrument, and we need about 5 days also to check out the instrument. We've actually allowed for up to a month to get both the bus and the instrument checked out, so we might get into a little bit of calibration in the second half of that month, but we'll be bringing down data from the instrument, kind of preliminary data, starting probably 5 or 6 days into the mission.
And then I guess maybe I can add to that, even that preliminary data is going to take a little bit of time to sort out and make sure that it's looking correct. And then we have a series of other algorithms, I guess you'd call them, that are going to process that data to try to understand aspects of the polar climate. So that'll take a little bit longer, but at the end of a couple of months, we do hope to be able to have new observations of what the clouds look like in the Arctic, what the surface characteristics look like, whether the ice sheet is melting or whether it's refreezing, and then also information about moisture in the Arctic, which is something that's very difficult to measure. As Karen pointed out, very hard to measure from the ground because it's very inhospitable there, but also very difficult to measure using any other existing satellite.
All right, moving on to the next question. We have Rachel Ramirez with CNN.
Hi, all. Thank you so much. My question was actually sort of the last question in terms of just how soon we would get sort of that data once the sats are launched. But how can you, I guess, give a timeline of how soon we can get that analysis post preliminary data, and where can we find it? Will it be on site? Will there be a press release? Just trying to get more information on that timeline. And then just the second part, and Tristan already touched on this a little bit, but I was hoping you could sort of expand more on how, that data can be used to improve or add to the accuracy of climate models, especially when we're telling stories about extreme events like wildfires or heat waves in the Arctic and whatnot. Thank you.
Tristan, do you want to take that one?
Yeah, sure. The first part in terms of the timeline, we do have plans, and I've been working with some of the people at NASA headquarters and at the Jet Propulsion Lab on this to release some imagery of the observations, the measurements that we make within hopefully about a month after launch. It's hard to promise an exact timeline on this because all of the programs that we've developed to analyze the data were developed without actually looking at real data. So we do have a whole bunch of different products developed, but we have to make sure that they're actually working before we release it to the public. But the goal is to have that sometime over the summer. Excuse me. But the answer to the climate model question is actually an excellent question. So we do have 2 climate modelers on the science team for PREFIRE. that's a fairly unique, again, feature of this mission is that we've incorporated a modeling group directly into the observation community here. And the goal is that we have some assumptions that climate models make about what ice surfaces do in terms of their emission, what the clouds in the polar regions look like. They're based on some aircraft observations from a couple of different projects that have gone on in the Arctic. But we've had this lack of information about that very critical region of the spectrum, these longer wavelengths, the far infrared, that we really don't have any observations about. So everything that is done in the climate model is typically based on a theory and not really verified using real observations. So the goal is working with these climate modeling teams is to actually, once we make the observations, directly give them that information so that they can improve those aspects of the climate model and make sure that the model is doing what we're observing from space. And then the climate modeling community can go ahead and do their usual experiments where they simulate future climate 100 years from now, 50 years from now, when carbon dioxide increases by maybe another, a few hundred parts per million. And they can see then how this new information has affected the temperature in the Arctic, the speed at which the glaciers in the Arctic are melting, and the speed at which sea level is rising. And then you mentioned some other impacts, and I'm glad you said that. They'll also be able to see whether or not the new information we provide changes the forecast for how many wildfires we might see, how dry it might become in certain regions, or how wet it might become in other regions, and how much snowfall we may be seeing, or what lack of snowfall we may actually end up encountering because of climate change, and then also how the coastal communities might be impacted by the sea level rise. So there's a lot of things that the climate model community then can answer once they have our observations incorporated into their models.
Rachel, this is Karen St. Germain. I just wanted to that was a great explanation, Tristan, and just to sort of amplify, one of the key things and one of the reasons we're so happy you all joined us today to try to help us tell the story is that I think generally people think what happens in the Arctic is far away and doesn't affect our lives. And I think in a lot of the ways that Tristan just mentioned, what happens in the Arctic really does affect lives around the world, and in pretty direct ways through weather and water availability and food security and that sort of thing. So really appreciate you drawing out the science question there.
We do not, at this moment, have any other questions on the line, so I'm going to bring us to a close unless someone presses *1 super quickly. Though I will offer, if Peter or Tristan or Mary or Karen, do you have anything you want to say to wrap up? Otherwise, I will close us out.
Well, just again, this is Karen. Thank you all for joining us. We are super excited about PREFIRE. It's a first-of-its-kind measurement looking at a really key aspect of what's happening in the polar regions that affects all of us around the world. And we're thrilled to have the launch coming up and can't wait to see what we learn from this new mission.
Anyone else have a last comment? If not, let me just finish us up by saying you can learn more about the mission at science.nasa.gov/mission/PREFIRE. There will be coverage from Rocket Lab of the launch in the U.S. in the wee hours of the morning of May 22nd, but May 22nd in general, wherever you are. We are going to finish us up. You can get a recording of it via emails that we have sent previously, and otherwise we are finished for now. So go NASA, go Electron, go PREFIRE.
Thank you, and that concludes today's conference. You may all disconnect at this time. Speakers, you may stand by for a post-conference.